But I've had a look, right? For legal, I reckon I'm looking at some assessments. Assessment 2, I've got 86 submissions out of 114, right? Surveying, I've got 88. This is everyone. This is all the whole of the South region, right? I've got 88 out of 112. For on-site supervision, I know assessment 4 and assessment 5 is sort of the time when it's all due, but I've still got 83 out of 115 for assessment 1. Assessment 2 are 71 out of... So I've sort of done a calculation, and I reckon 30% are going to fail, and that's not inclusive of the resubmissions and the ones that are struggling to actually get the stuff done. So that's just getting the work complete. So can you please go back, have a look? We're going to have to start locking stuff off because it's the end of the term, and we want the last 3 units is where we're going to start doing them at the end of the term. So we want all the other units to be complete. So we got those, 3, 6, 7 units to sort out the next couple of weeks, pretty much. So legal, I'm just giving you an NC. Apologies, but if you haven't submitted it, there's nothing we can do. Please send us a message. I know I've been banging on about this. Please send us a message if you've got an issue. You know, I had one student that's going to withdraw and come back and finish off next year, which is a really smart move. So he can't, he's not paper. So he's not going to have to pay. He'll just do it the subject next year, which is fine. You know, they're not actually hard subjects. You just got to do the work. Does that make sense, everyone? So I reckon 30%, and this is probably a bit of a shock for us because we've got bigger numbers this year, but there's loads of support. So remember, we're here 4:30 to 5:30 to answer any questions, and usually if you send us an email, there's not just myself, there's Glenn, there's Frank, there's Adrian, and then also we've got Stuart here on Thursday nights as well. So there's 5 of us. Oh, sorry, and Forksy as well at Nara. So there's more than enough support. So please let us know how you're going. And I suppose finally, apologies for those guys that are all over it, which is the majority. He's actually doing a great job. So I'm going to hand over now, Adrian, unless there's any questions or anyone wants to have a bit of a whinge or tell us how happy they are. So everyone all right? All right, I'm gonna shut up now. Thanks, Adrian. Thanks, everyone.
Thanks, Brett. Thanks very much for that. Can everybody hear me okay? Good to, is the sound coming through okay? Just a little bit of a feedback on the chat box is good. I'm going to assume that it's all coming through good. So that's real good. Now, what we were talking about there with Brett was to keep up with all this work. So make sure you message us or let us know. And there's that hour before the class starts where you can jump on and we'll help you out too. So there's no reason why you should be wondering how you're going to complete everything. So tonight what I'm going to do is go through S3, and I believe it should be all open up for you and the attendance choice should be right. Can I just have a confirmation that the attendance choice is working in the chat box? Yes, very good, they've said here, so that's great. So what we're going to look at tonight is a little bit about Assessment 1 Demolition Report. I may leave a little bit of conversation about that, some of that sort of work and what you did before towards the end. So I'll go through and get the content done and then get to the activities and open them up and give you time and help you with them so that you can feel confident that you can work on some of these activities real easily. So one of the first things that we've got here is that you should be subscribing to information that constantly comes in that tells you about new changes or things or accidents or dangers or hazards that are coming up. And here's an example of one that came through some time ago, but I just got one this last week while I was away that came through from SafeWork, and there's newsletters and things that come regularly. This particular one is a high risk safety alert for new on the spot fines, and this is to inform relevant staff and ensure your work health safety systems are up to date. So there's a little story there, and that is a couple of years old, but I want to emphasize to you that this information is on SafeWorks website and it comes through regularly, and you need to subscribe to some of this stuff now so that just like you get Facebook notifications or Instagram or anything else that you subscribe to, you also need to add now SafeWork New South Wales as your for your notifications, so you can keep up to date with what's happening. You need to make sure that you're finding out about some of the latest things that are happening, and there are things that happen quite regularly. So now we're going to have a little look here at some site establishment with the National Parks and Wildlife Service site that Brett was involved in down in Narooma. And this is an example of one of the activities that you had for last night or last week that Frank was working on with you. And here's an example of how the site is actually showing you that you need some sort of a description at some point as to where you're going to place things on the site. Now, not sure if you've been and had a look at that site now, that one that Glenn did, but it's on Google Images, and you can see there that it's all worked out pretty good. But somewhere on a site, when you often don't have much room, you've got to have a good plan in place to be able to know where to put everything. And this is all part of, you'd have to put something like this in for a demolition plan if there were things that you had to remove. And so in this particular example, you'd have a code somewhere, and your B could be your bricks, for example. S could be sand. You could have your piles of things there. You're going to have spots on your sites for your rubbish, and you're going to need to have a place where you can put all these things so that you can, and you know where they're going to go before you even start. You have to have that all planned before you go and start. So not too sure whether you wanted to play. This was an activity actually, so I think I can probably show that, but Brett, you just turn it off if you didn't want that left up there. And I just want to show you the NPWS site today. And if you went to Google satellite view and you had a look at that, that's kind of what it looks like. There's trees everywhere now, and the job's all been finished. But you don't get to a job like that that's completely finished without having a plan in place. And so it's real important that you come up with a site plan before you even go too far, so that you know where to tell the trucks when they start delivering sand and bricks and materials onto the site. You have to make sure that you know where things are going to go. And part of that has to be done on a demolition report. So we're going to have a little quick look now at the assessment one, which is open for you for the demolition report. And I made put a couple of things up on here specifically for Wollongong, but every council and local government authority has this information available to you. And so what I want to talk about here briefly now is what happens when we have to do demolition, because demolition is something that often has to occur before you can do some building. And so there's a little bit of information that comes up here, gives us a little bit of information about is demolition part of the development application process. And in the case of demolition, full details of the age and condition of the buildings or works to be demolished must be provided. You must also provide photographs of the building to be demolished. So demolition is going to require a lot of different things. And if you have to demolish something to be able to build something new, then you're going to have to put in a plan in most cases to be able to demolish it. I'm going to show you the Wollongong Development Control Plan, which I've made available to you there, and that's going to take you to the site for Wollongong for the Development Control Plan. It's a really big plan. In fact, it's so big that they've broken it up into chapters that you can see here. And as you go through, there is one down the bottom here that deals with demolition that comes through. You've got all this information through here, and then we come through to the actual demolition plan, and it talks here about this particular one is one of the chapters, and that's I'll show these next two, but the one that I particularly want to focus on is this one here, E21, because E21 is the demolition of hazardous building materials management. And you can see there's a whole book here, which is 8 pages. That looks pretty good for us landlubbers inland here. So you can see this is demolition and hazardous building materials management. And here's an example of some of the things that they're going to talk about. They're going to give you an introduction, some of the objectives as to why they've produced a booklet like this, some definitions, and that's always at the front of these legal documents so that everybody knows that the term they're using or the word they're using relates to the particular, the same thing right across the whole board, and then it relates to relevant legislation. And then we've got Environmental Planning and Assessment Act 1979, and Wollongong looks like you're operating under a 10-year-old local environment plan. Now Wagga has a local environment plan, Griffith has one, Moruya, everybody's got a local environment plan, because all local government authorities have to develop these based on the Environmental Planning Assessment Act, and also on, it's usually added onto from development control plan, because the local government authority is in charge of all the development within their region, and that's because they're closer to the people who live in the region, and so they can take into account the types of things that the local people would like, hopefully, when they develop their plan. And you have input every 5-10 years or so when they make a new plan to be able to have a say as to, you know, how far you want the building set back, what development you want to occur in different areas. What about that massive development that's down at Shell Harbour? There would have been a lot of local input into that, hopefully. And then the developers have to meet certain guidelines to be able to do things. And if there's any demolition involved, that's where this all comes in. So we've obviously got to adhere to the work health safety regulation, protection of environmental operations, and then we come to demolition of buildings. And this is what relates particularly to your assignment number 1, the demolition work plan. So let's just have a skip down here and have a quick look at some of this. This will be a really good document for you to be able to use as a base. So we've got our act here. Activity must be carried out within a property. Must be a demolition of an entire structure, not part of a structure. So this is dealing with under Schedule 2 of the LEP. Certain minor demolition work may be classified as exempt where it is in compliance with the following requirements. Okay, so we've got work health safety, we've got protection of environmental operations and demolitions of buildings. So there's an Australian standard for demolition of structures right there, 2601. That will be the one you'd want to be familiar with, and that's going to talk about a lot of structural technical details to do with demolition, and that's the one that we have to carry demolition out in accordance to. It says must be carried out in accordance with that standard. Here's the demolition work plan, and if you look at this goes from 5.1 right down to, it's got to 16. 16 points there. That's pretty similar to the sort of things you have to do on your assessment 1. It says here, any development application lodged for the demolition of a building or structure must include a demolition work plan. Should include the following information: site location plan. Okay, so we talked about that a minute ago. I showed you the one from the national, the parks and service down there at Narooma. And that was a location plan of the new building, but there would also be one showing the building or structure which is proposed to be demolished. Need names and addresses always, and contact details. Details of any qualifications or experiences. May be that you need asbestos removal people, so that information would need to be there. The height of structures, that's because the higher things are, the more dangerous they become. We also need the type of building, the footings, structural steel, concrete components, whether it's been pre-stressed or post-stressed steel in the building. Some of large commercial buildings have that type of concrete, and you can't just start jackhammering it because it may explode on you and kill people. We'd need a detailed list of hazardous material. Okay, we'd need, and as soon as you start to talk about asbestos, for example, then there would have to be a plan in there for how to remove that asbestos, even to the stage of having a map of the directions from the asbestos site through to the final disposal site, and showing the time of day of when you're going to go, in case work cover want to drive behind you that particular time and make sure that bits of asbestos aren't falling off on the side of the road. So even that has to be done. Details of methods of demolition proposed, what type of equipment you're going to use. So that information right there would be real helpful for you for your assignment. And just to refresh your memory again about where that's found, that can be found right here on tonight's lesson. Okay, so then there's one here called waste management, which I want to show you, and this is an overall part here, 33 pages on this one about managing waste, and there'll be something there to do with specifically for demolition. You can see there, I think it might go straight through it to it. There it is. So this talks here, quite a bit of information here about how there's a page and a half there about demolition and how we need to be the things we have to take into account. So you would want to read that before you do your demolition work plan. For example, identify all waste likely to result from the demolition and opportunities of reuse of materials. Facilitate reuse or recycling. We come down here, allocate, relates to a plan there, allocate an area for the storage of materials for use, recycling and disposal. Those sorts of things need to be taken into account, separate bins. clearly signpost the areas. So this should help you with assessment number 1. Then you go through here and they keep on going down. They've got a table here and they've got examples of demolition materials and potential reuse recycling options. Look at all the materials there, 10, 15 materials there that are listed. And if you have any of those on your site that you're planning for your demolition, you would want to make a note of how you plan to demolish those. So I'm going to go right back here to this part. So this is all part of your helps here for tonight on S3 for assessment 3. When I go through to this one and show you this one, why are we completing a demolition report? And this particular one is because when you look at development application forms and checklists, this is what you do when you want to build a new building in Wollongong, and every local authority has this. If we look at a checklist, there's a demolition option down here. And if I scroll down here to the demolition one, which is down towards the bottom, I think I found it. Just do a quick search for that one. There we go, the demolition, and there's I'll call up the checklist. And here's the check here, for example, is the checklist, application for demolition only. So you'd read all that through. Please tick each box, document transmittal, see reverse of this checklist. So that'll be over the page, which is just here for documents and things, plan number, revision number, date, author, things like that. So they want to see all the paperwork that goes with this application. Then you've got all the normal things there, like who it is, any disclosures or anything, correct fees, and that information there is possibly going to be assisted by the person in the council to be able to fill that in. And then they need copies of documentation, statement of environmental effects, as per, etc., etc. You go and find that. Need a location plan. There's that location plan once again. We need a site plan. So there's all the information there, including the scale, showing a north point of all the information that they want. And there's the demolition details, and that's those 2 documents that I just showed you, E7 and E21. And E21 was the most useful one there for us. Okay, so I'm just going to go back up here. So all that information there is on, we're still on S3. You can see S3 for today's lesson, and you can see this is help for assessment 1, and there's some help for you as you go through to be able to do that. And then there's a information being put in here for you, a little bit about assessment 1 updated. And this is pretty much the sort of things we're looking for assessment 1. So you can see reason for demolition. What is the building, location, height, distance? You remember me showing you that on the Wollongong demolition site there. Then we've got any legislation requirements, what type of building, list the building material types, services to be disconnected, what are the demolition methods. So a lot of this has been shown to you there. What's your waste management plan? Refer to your workhouse safety management plan, and photographs. And the questions just come through to me here. Are we just making that up? So let's go back to the. I'll just open up another one here and have a look at the assignment, because I'm probably getting a few questions on that. So Brett said there, remember licensing requirements from last week, maybe save it and add it to your builders file packages. So I've put some things into your builders file packages. The question I've had here, are we just making that up? Let's have a look at what the assessment actually says. So we go to assessment 1. Of course, you've got to check, acknowledge that you understand how you're going to be assessed before you can do any of these. So make sure you tick that. And here's assessment 1. It says provide a proposal to demolish the elements of a structure. Complete a demolition plan for part A residential and part B commercial. Now, you all know what residential and commercial is now. That's going to be, as soon as you see those, that's going to be referring to a classification of the building. And there's 10 classifications, and quite a few of them are for residential and quite a few of them are not residential. So it says see document attached as a guideline for your report. And this is the one that I just pretty much showed you then, which is just coming up on here. And that's items to consider. So I've got somebody coming in on the speaker here. Maybe just type in the chat box if you've got some more clarification on that, Brett, because I wasn't here last week actually. So that's your assessment 1. Is there any clarification on this? I've got someone asking here 2 reports. I might let Brett clarify that a little bit more. So Brett, the guys are asking me, does assessment 2 consist of 2 reports, one for residential and one for commercial, as per assessment 1, sorry, as per these guidelines? We'll just watch the chat box here, everyone, and see what the response there is.
Guys, can you hear? Yeah. Sorry.
Oh, good. Yeah, go, Brett.
Can you open up the demolition report guideline?
Yep.
Yeah, that Word document. Okay, so there's part A, part B, right? So,
okay,
as painful as it is, to be honest, if you do a residential demolition report, I would pretty much say as a assessor or a teacher, I would know that you're competent to be able to fill a whole one out. But the actual unit, we're doing apply structural principles to residential and commercial. So we need to for you to show evidence that you understand how to do a demolition report for a residential and a commercial job, right? So you actually need to do on that screen see from questions 1, if you can scroll down for us, Adrian, to, I think there's 20, is there? 20 questions?
13.
13, sorry, my mistake, 13. Put up the top there, maybe Adrian put up the top, part A, right? Part A, residential, and you need to write about it. Class 1A building, I'm going to demolish my house for a subdivision. That might be a reason. Yeah? Then copy all those questions, and maybe we might fix this up. I might fix this up tomorrow, make it easier for everyone to understand.
Yeah.
Copy all those questions, go down underneath it, go part B, commercial, and you say, attach all those 13 questions, and you're going to say, first, the reason for demolition is I'm going to blow up and implode the TAFE building because I'm sick of Brett talking, or something like that. I don't know.
Yeah.
Does that make sense?
So that does make sense. That's good. Anybody else got any questions there? If you've got a, I see Craig's asking there, if you've got a restricted demo license, is this possible part of RPL? Talk to your local teacher about that. Good question. So that's raised a really good point, though. There are actual licenses regarding some of this type of work. But for this particular activity, to be honest with you, the easiest thing to do to pass this unit is to grab that information, and Brett's going to make some adjustments to it on the site there, and call one of them residential and one commercial, and answer the information. Put the pictures in, pick a building somewhere. I mean, I would pick an old building, obviously, and you can do that real easy. Now, I've got one student who is not actually working on building sites. Look, this is what I would probably do, which I'm pretty sure would be okay. You just jump on maps somewhere, go and find yourself an old building that looks like it needs demolition, and grab some photos of it. Go and get as much information as you can. Pick yourself an old area of town. And I know one that happened just recently, there was a fire. So why couldn't you do this as a desktop type thing and then go out and visit the building? Just be very careful going and taking pictures of people's buildings. But you can either go in and ask people, and just say it's part of an assignment, or you can actually, grab some photos and debadge the building. So there was a fire. There was a fire down this street a couple of weeks ago, the last building on the end, and a couple of our good old students here from TAFE have been doing it up. So this particular building looks quite different today because it pretty much burnt down. So you could pick a building like that. Why couldn't you do something like that and get all the relevant information and put that into your assignment? Obviously, just be cautious, because I was doing an assignment like this years ago, and someone came out the front with shaking their hand at me saying, "What are you doing taking pictures of my building?" And I had to explain to them kindly I was doing an assignment, and I promise I'll block out your street address and everything. So just be cautious of that. So hopefully that helps. Are there any other questions about that's a good point that Brett's made there. Try and use your own building if you can. Pick a commercial building somewhere. You're welcome to use the TAFE or something like that. Just be conscious of private property and conscious of some of those issues that you might have. Public buildings like hostels, the bigger the more public the building is, the more cautious you've got to be, because these days we don't want people walking around taking photos of things that could raise a few eyebrows. So just be careful, but be cautious, and if need be, just ask someone. you definitely could pick a TAFE building, and I'm sure there's an old one somewhere that you could get some information on. So I'm going to assume that everybody's pretty right with that. And if you have more questions as you start working on it, definitely take advantage of the 4:30 to 5:30 sessions, because this isn't really that hard to do a couple of pages on a demolition report. And so I think that should be pretty good. So somebody just turn their microphone off if you would, please. What we're going to do now then is we're going to move on to some more we go. Someone unmuted me, so I'm back on again now. Not sure how much of that you heard, but I'm going to move on now to foundations and tonight's work. And you can see pretty much what we've got here is a quote about foundation classifications. Now you know a lot of this already now, because we've already been through the classifications of buildings from the National Construction Code, and we're going to look at it tonight from the point of view excuse me, from the point of view of the Australian Standard 2870, residential slabs and footings. But there's a little quote that I just want you to think about. The function of the building is to transfer the structural loads from a building safely into the ground. Every building needs a footing of some kind. A backyard tool shed will not be damaged by slight movement of its footings and foundations, and may need only wooden skids to spread its load across a sufficient area of the surface of the ground. A house needs greater stability than a tool shed, so its footings reaches through the unstable surface to underlying soil that is free from organic matter. A large building of masonry, steel or concrete weighs many times more than a house, and its footings must probe into the earth until they reach solid rock that is competent to carry its massive loads. So this is going to start introducing into some of the more complex structural discussions, where we talk about the fact that because we operate on a system of gravity, all loads are going to be transferring almost straight down, depending on the direction of some of the other things that affect our loads. So I'm going to quickly have a look at this PowerPoint here and show you as soon as that uploads. And I think that should be coming across to you there now. And I want to quickly just flick through this, because there's quite a good little introduction here to you on foundations and footings. So remember, foundation, the term foundation, the definition, foundation is ground which supports the building. Okay, and there's a thing called the allowable bearing pressure. Those three words that you can see there, allowable bearing pressure, is a legal definition that's at the beginning of Australian Standard 2870. And it means the ability of the soil to carry a load without excessive settlement. If you see capital letters ABP, that means allowable bearing pressure. Okay. For example, for 1- and 2-story buildings, the NCC, you can see I've just abbreviated now because we know now this means NCC, not BCA, requires that about 100 kPa, for example, might be under strip and pad footing and 50 under slab footings. So kPa is kilopascals, and it's written with little k, capital P, little a. That's the international standard way of writing that. Every time you write that, you should have little k, capital P, little a. Right across the world, that's understood to mean kilopascals, which relates to the weight of gravity plus the weight of the item itself. Okay, so one of the problems that we come across with buildings is reactive soil. And if you go, how far is Hay west of here, you guys? 3 hours? 3 hours, 3.5 hours west of here to a town called Hay, you'll come to highly reactive soils. And if you were to go there and look at the Hay Courthouse, we could go for an excursion, but we'd run a little bit late tonight. If you had a look at the Hay Courthouse, it's built so that all the main load bearing is down below the building, below all the reactive soil, which is on the top half a metre or metre or so of the soil. Because out at Hay, it gets real dry in summer and dry in winter the last 6 or 7 years. But if it does get wet, it expands a lot, and the soil can grow in height. If you were to measure it against sea level, for example, it will grow in height by maybe a couple of 100 mil. And so the building has marks up and down the buildings, big solid buildings, and they build the footing so that it goes right down to the non-reactive soil. Over in Canada and Alaska, they have a thing called frost heave. So when you're driving along the road, it looks like you're driving down a real bumpy road, because the ground freezes and expands and contracts. And that's the technical reason as to how it expands and contracts. And that's a bit more about how it expands and contracts. It's a little bit technical, but the main thing to remember is that the volume changes. And that can be bad for us, because if we have wet clay soils on half the building and dry clay soils on the other half, we might have this sort of a problem, okay, shown by this diagram here. If the outside of our building gets dry and the inside's damp because there might be a leak or because the outside's dried out real quick, we might not have enough support under the outside of the building. Or if the outside of the building gets wet and the moisture hasn't transferred into the inside, we might have a bit of the inside of the building that's just sitting there not being supported. Are you laughing at me? I thought I must have said something funny. And this is what can happen with a bit of a problem that can happen with buildings. So of course the next point is, who's ever seen a building with a crack in it? And I think everybody has. And that's an example of it. And there's two main types of cracks in buildings with masonry. One crack will follow through the brick and just go in a line, and the other one will follow the brickwork, go along the mortar. So if it goes along the mortar, that's generally not quite so bad. If it's going straight through the bricks, irrespective of the mortar, that's usually a little bit more sudden, and that's a little bit more urgent, that something might need to be done about it. It might not need to be done about it, but it might need to be done about it. So this is all because the foundation moves. Predominantly with buildings these days, we're always trying to build so that the structure, which is the footings, can support the building on the particular foundation that we're dealing with, which is these types of foundations, so that we don't have any cracks. And so this table's taken straight from Australian Standard 2870, which I'll go straight to and show you, because I think I'll keep showing you here actually, because we've got a little bit more to go. This table explains the classification of damage with reference to walls. And this shows us, for example, if we have hairline cracks that are less than 1 millimetre, do you all understand what that little wedge shape means like that? It means everything on the left is less than 1.1, and that's damage category 0. But if we come down to here to the most extreme one, this one here has 15, so the approximate crack width limit, 15 to 25 mil, but also depends on number of cracks, is damage category 4. You can see how it's been categorized, because then you can make decisions on what to do, and people can do inspection reports and make notes on what sort of costs might be involved. You can see with this particular category, extensive repair work involving breaking out and replacing sections of walls, especially over doors and windows. Window and door frames distort, walls lean or bulge, and you can read the rest of that easy enough. So that's an example of from 0.1 through to even 25 millimeters of gaps and cracks and things that appear. That's an example of what you can have. So the BCA states, due to the limitations of this part, if a site is classified as E and P, then reference against it must be made. So here's an example of all the classifications. And these bottom two that note was just talking about, basically saying you're going to need an engineer to work on these two sites. These ones up the top here, there's 5 of them. You could actually specify your own footings, which you're going to do as part of an activity tonight. You could specify the type of steel, the cover of the steel, the type of concrete, the thickness of the concrete, and everything yourself. This is all an engineer is going to do for you. They're going to look at the classification of the soil and say, it's S, it's fairly stable or slightly reactive. And so if it's an S-type soil, then we can go to a chart and look it up, and we can determine how thick the footings need to be and what type of steel and things like that. So this table here is basically a summary from the construction code. But we don't know what type of soil it is unless we're soil experts. And we have to identify the soil profile using established and existing data. In most cases, I would probably say 99.9% of the time in a new building, we would get a geotechnical report. And that geotechnical report is going to take some soil back. They're going to put a little bit in a container and put a certain amount of, they're going to weigh it. They're going to put a certain amount of water in, and then they're going to weigh it, and they're going to measure how far it's moved and all sorts of fancy things. They go to university for 4 years full time to learn how to do that. So obviously it's pretty complicated. And then they come out and they're able to say how reactive the soil is. So soil mechanics. Thank you. I have an engineer sitting behind me, keeps me on track, and he said it's soil mechanics. But you have to know what you're doing with that, and that's why we get a thing called a geotechnical report. And there's people in your region who do that, and I would say probably most of you have seen that listed somewhere. If you get the engineer's details of the plans, and it'll say on there what the soil type is, and that's usually come from the engineer who has done a test in any one of a number of ways. And here's an example here. So it says here in 2870, a minimum of 1 borehole or pit per house site, or B is a minimum of 3 boreholes per site. So here's an example of what they do. Note the guarding around that spinning drill bit, which they have, and they're going to come out, put a little trailer down there, they're going to drill a hole, and then they're going to put it into a case like that, take it back and test it, and put it through all sorts of scientific tests. Does that make sense? So that's called soil classification. That's the way to really classify soils. And I'll go to part 2 of the Australian Standard 2870, which I've fired up for you all here. And you can see there's the chart there, the table. And I want to just throw the chat line open here so that you can tell me what your experience has been about who's ever seen a soil test classification before, and what's the most severe one anyone's ever seen. Just put it on the chat pod there. So I'll just open up a couple more things here. What's the most severe type of classification that anybody's ever seen when you look at classification? So A is the most stable. It's great to build on A. Sydney, a lot of Sydney City is built on A. And then when you go to extremely reactive sites, or H2, they may have been maybe even fill sites. Okay, in fact, P is a fill site. So sites that have been filled and things like that, and it talks about this here. Okay, can get to H2 around Hay on the River. Thanks for that, Craig. Very good. So it can get very, very expansive, and we've got to take that into account. So 90% of the time, we're going to have to choose a footing type that'll be able to give us some resistance about that. I gather in Wollongong, most of you, and up and down the coast, you've got a fair bit of difference between rock and also alluvial type soil. So it's the alluvial soils which can create problems. We have a lot of that in Central Wagga as well, where we have alluvial soils, and in some cases you dig down a couple hundred mils, I know probably 300 or 400 mil, and you've hit the water table, and after that it can be soggy. So you just got to make sure that you've got an engineer to be able to design it all. So thanks, Riley. Riley said H2 House and Gully had to have collars on all the plumbing under slabs. So that's right. So there's lots of extra things that have got to be done. Now, the good news here is about this topic that you don't have to be the expert. In fact, you shouldn't be the expert. You should always rely on somebody else. You can do a certain amount yourself, but you really want to rely on somebody else to be able to give you the documentation to confirm what is actually required to be built. So here's an example of some of the different types of footings. And so when we look at the Australian Standard 2870, which this picture has been taken from, can you guys stop talking there, please? When we look at this one, we can see there's an example of some of the different types of footings. So you pretty much, most of you would have had something to do with a strip footing, a pad blob footing, raft slab, pier and beam, thickened edge beam attached to the slab. So we've got a whole lot of different types here. Here's a strip footing, which has a thickened edge beam sat on top of it. And so here's, in this particular case, it could be an internal beam because we have waffle pods that are keeping it apart. So we also can have thickened edge beams here, and the depth of that, the D there, is going to determine a lot of the strength, just like a beam above a window. The D is going to determine a lot of the strength between the different points. Okay, so you all should make sure that we refer to that particular wording that's there, and that's the legal definitions for the different types of footings that we come across. Okay, so we have, and I've got the points being made here. We have, did you say 5 foundations? Yep. So we're going to go into foundations we broadly looked at our foundations there, but the main foundations we're going to be dealing with will be given to us from our soil geotechnical report that we get. So when we look at how reinforced concrete works, we'll drop over to this one, and we can see reinforced concrete is basically concrete, because concrete itself is really good for compression, but it's not so good for tension. But steel is real good for tension, but not much good for compression. We put the two together and we have reinforced concrete, which forms a really strong structure, which is used almost everywhere in construction these days. And there's a lot of good information on how that works there. We can do lots of different things rather than just pour concrete around steel and have reinforced concrete. We can have pre-stressed reinforced concrete. We can have post-stressed reinforced concrete, or where we stress the iron and then pour concrete on top and then allow the stresses to let go with clamps at the end to pull stress on it. Or we can put conduit through the concrete and then pull wires real tight through them. And those things are very specialist, and you want to know what you're doing when you're dealing with that type of work. So as far as concrete, when you look at the history of concrete, it comes from lime and a number of other things. They cook the lime, and you can read information, see plenty of information about how it works. But it was invented, I think it was only about 180 years ago, 1853. They started working on iron and reinforced concrete structures. Concrete was used well before that, but when they put steel and iron together, that's when they started to make some real unique buildings. And that's where they're able to, you can see all those words there, and you can look that up yourselves. You look up the history of it. But basically, it's given us the ability to be able to do all sorts of building structures, so that you could probably walk outside and look around any commercial site anywhere, and you'd see this as a very, very common site. Okay, we just have masses and masses of steel that's separated until the concrete gets in there, and then concrete's poured across the whole thing to give you a smooth surface, but it's full of steel. Okay, and so we've got a good article there on all the different types of types of concrete that we can have, reinforced concrete. Look at it all. We can have problems with concrete. That'll all go through there, and I'm going to let you read that yourselves. That's an article that's opened up there for you to be able to have a look at. We're going to look now at this next point, which is types of footing systems. And so when we look at the footing systems that are on here, you can see here's an example of different footing systems. Just take it straight from Google Images. You'll see there's heaps and heaps of different types. In Australia, we must make sure that we work to either Australian Standard 2870, or an engineer can design things themselves, because remember, the National Construction Code says you can have something that's not specified, but then they have to have their own testing for it. And you can see that pretty much that's common what you'd see on any building site around a lot of the cities and towns today. We're going to have these trenches or beams of concrete formed up with steel, and then we have a layer on top, might be 50 millimeters to 60, 70 millimeters, maybe a little bit more on the coast, or a little less in some stable areas, and that forms a pattern that can be give us a real strong floor and base for the building. And then this is pretty much your strip footings, which is very common. So you guys can have a look at that, and girls, and see how that all fits in. Then we go to hairline damage table, which I just showed you earlier. And I want to, while we're on this, I just want to show you the an example here of our New South Wales guides to standards and tolerances. Oh, they've got a 2019 one coming out as a new one. I'm not sure whether that's going to be the 29 one. I'll go to the actual website so you can see. This is going to be a guide to the standards and tolerances, and this is for buildings. Okay, and there's they go to the 2017 one. There is only the 2017 one at this stage, and this is like your little guidebook. It says at the beginning that it's not going to be your legal guidebook, but it's a real good summary of the different things that you need to be aware of. So when you look in here for things like cracks in concrete slabs, this will take you to Australian Standard 2870 there somewhere. But the average layperson can't understand that. So here we have an example of some of the different ones that are here. This is pretty much taken from that, but just dumbed down just a tiny little bit. You can see that's been taken from there. And this is an example of the crack. So people will come up to you, and the guy, friend asked me recently, can you go and have a look at a house that my daughter's thinking of buying, brand new house, reputable builder in Wagga, and said there's some little cracks in the slab in the garage. I'm not sure whether they're significant or not. And so I just referred him to this document and said, read this first and get to and measure it up against what you see, because there's a couple of things you've got to remember. Is that some things are allowed, they're just part of normal variation with construction and with buildings, but some things aren't allowed. But you have to remember that there's a thing called a normal viewing angle for things. And we've talked about this already, where you can't get a microscope up next to the floor and say, I can see a little crack. You got to see what you would normally view it from. And that's the key thing with these things. So you need to have a look at, need to be aware of that information so that you a knowledgeable person when you go and talk to people about what is normal and what is just a variation with building. So I'm just going to have a look at a video now. If you can prime up your videos, what if a footing system is not sufficient enough? And so I'm going to show you this 1.5 minute video on pile driving, and this is a way of being able to achieve piers, tall piers into a building site, so that you can obtain enough strength to be able to give resistance for the building so it can be stable. Now, pretty much as you watch this, I want you to think, don't know if anybody's ever been to Venice, but Venice is basically built on timber piles like this. So the history of it is that years ago, probably about 200 years ago, people felt a bit insecure on the coast, and so they fled out to some of the islands out there, and that was pretty hard for people in ships to come and chase them. But the islands weren't real good to live on because the tide came up a bit, got boggy, got wet feet. So they started getting piers like this and driving piers into the ground. And they used timber because even today, if you go and look at a lot of the piers around the coast, a lot of them are still timber, because we can get some timbers that are more durable than concrete and steel, and they can resist termites and all sorts of things. So they drive the timber down, put the buildings on top, and pretty much the city's built on that. There are a lot of structural buildings are like that. Newcastle TAFE has some of their buildings that are built like this. They may not be timber, they might be concrete, reinforced concrete, or they might be steel. And so the concept here is that you're going to pretty much like if some of you go camping these days, you'll get a big long roofing screw, put it on the end of your impact driver and drive it in the ground and tie your tent to that. And the concept here is the opposite, is that we're going to put weight on top of this big pile, and it's going to be sufficiently embedded in the ground that it won't go any lower with the weight of the building that's on it. If we increase the weight of the building by doing a major renovation or extension or addition, then we might need to have more piering underneath it. But for the initial construction, it would have been determined by the engineers that a certain number of piles embedded a certain distance with a certain resistance into the ground would be sufficient to be able to support this building. So we're just going to have a look at this, and I hope the video works on our Wagga screen here, and then type in the chat pod when you're finished. Must be soft ground. good point. Somebody said we've got to show the video. Sorry about that. I did need to do that. Thanks. Hopefully somebody else showed that while I missed it. Sorry about that little hiccup, but look, the concept there you can see is pretty straightforward. And I reckon if anybody's on if we've got any farmers amongst us, you've probably used that same principle these days to drive your star posts into the ground. And that's where you'll just have an air driven possibly. Do you guys have star post drivers like this on your farms? Yep, they live right in the middle of town. Do you? You do or you don't? Yeah, he does. You have a star post driver and you just put it on top, and the constant hammering just means you can stand back and just steer it into the ground. And you can see this thing just steers it. So this is a pretty common thing for really large construction sites. Okay, and so that's all good. And then that's an example of real large commercial construction sites. I'm just going to show this next one here, which we're up to. Now Wagga, maybe I'll just I can't actually show you any pictures at the moment because I haven't got them there, but Wagga at the moment's getting a new hospital built, and for their piers they drilled about, I think, correct me if I'm wrong, about 30 meters into the ground holes, and then they as they down the middle of the drill they had a hole to pour concrete, so they poured wet concrete, and then the drill pulled out of the way, and now we've got a hole 30 meter deep, probably almost a metre round hole that's been filled with concrete, and the next crane quickly moves over and drops a round cage into that hole and pushes it down as far as they can, and they get it about 2/3 of the way down, and then they cut the top off, and that's what they let that cure, and that becomes the piers for the building. So that's a different way of doing construction. Obviously they're not driving them in, but concrete piers can be driven in. So this time I'll show this video before I put it up here, and we'll have a look at this next video, which is to do with the it's a different PeerTech type system, and then we'll join with you after we finish this one. How are we going? People finished? Wollongong done? Okay, so I had a comment here which was, isn't there a material that can be pumped underneath to raise it up? And there is. There's lots of different systems. There's people can come out and inject material in underneath, and it'll just keep squirting out until it jacks a building up with a high pressure system. There's lots and lots of different systems. All of them are very expensive, and they're a stopgap that can fix something that shouldn't have gone wrong in the first place. But from time to time, things do go wrong with buildings, and you can have faults. So some of these are going to require major work. I heard of a case recently where a building was bought. About a year later, the person's found that it really needs jacking up to fix it properly, and it could be $80,000 to jack it up and fix it. And that's just a normal building in a normal town around here. So someone's seen expander foam version, didn't work very well. Thanks, Dan. Yep. So professionals will come in and do things, and they'll give you an idea of whether it'll work or not. Someone did 140, Craig did 165 square meters, was about 40 grand, pretty dear. So I did get some price on one a while back to lift up some concrete slabs, and it would have been like 8 to 10 grand for just straightening some concrete slabs in some driveways, probably a 30-metre long driveway with 6 or 8 slabs that just needed realigning. So the alternative for buildings is sometimes to pull things down and to change them around and redo them and things like that. So you just got to have a look at that and see. I'm just going to go through now and show this next item here, which is dealing with the pier and beam. So there's an example of going to let you play that one yourselves. Actually, that's a video there on the pier and beam. I'll just get through the ad here. Stay with us. That looks like we can't get past the ad. No, I'm going to let you play that one yourselves. So that's that video there on pier and beam, and then screw piles that are here. We're up to 6:30, so I'm just conscious I don't want to take too much more of your time without you doing some activities. There's screw piles there, which is another quick video you can look at yourselves of some different methods that are available. Now, by now, everybody should be having access to the Australian standards, and you should also have access to the National Construction Code. Just remember, use your normal username and TAFE username and password to be able to access those. And then we have a quick PowerPoint here on strip footing design. And then I want to quickly get onto some of the activities for tonight. So we've got the strip footing design that's coming through here, and just pump that one up to the full screen, so I think you can see that okay. And just show the whole thing there. So you can see proposed strip footing, for example, Class 1A building, timber clad frame, stable site, no internal load bearing walls, ensure footing size and reinforcement is to be used. And so in this particular location, this particular exercise, how do you find this information? So we go to the National Construction Code, footings and slabs, and it'll either refer us through to 2870 or give us some more information within the National Construction Code. Normally, National Construction Code these days just takes us straight to the Australian standard. And here's an example of what we may end up with. So these are just hand-drawn sketches, and if you get an engineer to come out to your site, you should be able to sketch these sketches off the top of your head for sizes and things, and you can look up all this information. So the D is the depth of the footing is 400. The B is going to be the breadth at 300, and it'll tell you the size of the steel that goes inside that footing. Okay, you got to check your notes. There's always notes underneath these things, and you need to check them and make sure that they all relate as well. That's a little PowerPoint that's there for you. Just shut that one down. That's a PowerPoint that can help you with your strip footing design. Okay, and then we've got information here on a commercial design, and this is an example from a job that Brett was involved in and can tell us a bit more about We might even grab Brett in a second to chat a little bit more about this, but I want to open up the chat pod so that you can get yourselves a little green box. And you can see on this particular one, I think that's opened up. There's the National Public Works System. This particular activity, I'll just go back here so we can keep our original page open here. This particular chat box has been opened for you. And what it's asking you to do here is to refer to the National Construction Code and comment on the best way of designing a commercial footing system for a Class 5 office space. There is this is a one sentence answer. Think about it as a builder. What's the best way to get this design? So we're thinking from a point of view of a Class 5 office space. And here's an example of an office space. And we want to have a look and think from the point of view of the National Construction Code of how could we design the footing for it. So here's Brett's job. Actually, are you online there, Brett? Do you want to talk about this job? Or have you disappeared there? Not quite sure whether Brett's not available. No worries, I'll go through it with you. I had a chat about this with Brett earlier. Who's coming on there? Is that you, Brett? Or Glenn? Nope. That's okay. I can work through with this one. So we've got a Class 5 building, which Brett built down at Narooma, you worked with years ago. Let's just say he built it because look, it's a nice looking building, isn't it? And that's an example of office spaces and things. And so how do you go about designing the footings for something like that? That's the inside of the building. This is fairly well, you've got load bearing on the outside. You've probably got some load points here and here and here, all the way through there with columns. I would say that looks like a bit of a portal frame construction. I can see a framework coming up here, across there, down there, probably another one there. So what do you think we're going to have underneath each of these columns? We'll have steel behind there, those timber covers possibly. We're almost certainly going to have piers in underneath that, which could be in the form of a driven pier, just near the water in Narooma it is, near the waterfront. So it could be a alluvial type soil, but we're definitely going to have some sort of extra strength under there. We're not really going to need anything more than a floating floor slab here in the middle because there's no load other than just the normal office type load. Okay, so as we look at this building, there's an example of the plans for it. Now you can't read that and you don't really need to, but you've all seen plans like that where it's got all that information. Look at these drawings and all these tables. They're probably taken as a copy straight from an Australian standard. It's probably general information from an Australian standard, but the engineer grabs it all out of the Australian standard and puts it all into a document and then adapts it for this particular job. Look at that example right there. That's probably taken from an Australian standard, and the details there, this keyed joint, KJ, is probably what you would find in the Australian standard, but they use codes and things like that. And then over here, there'd be key joint listed in here somewhere. You can see that all blends in, so that we've got all this standard type information. It's been drawn specifically for this job, but that's an example of where they get the information from. Somewhere over here, it'll say refer to NCC or an Australian standard, possibly 2870. If they've designed some particular product by themselves, then they will have referred to those technical details for that particular product, like those piers that were being driven in with a machine as a screw jack type pile. That would have its own engineering details. It's not listed in the, it's not even in, the word helical is not even in that Australian standard. So let's have a look at this little chat box here so that you can get yourself a little brownie point. And the question here is, referring to the NCC and comment on the best way of designing a commercial footing system for a Class 5 space. You shouldn't need any more than one sentence for that. Anybody willing to have a go? How could we design the footing system for that job? Let's have a look at what Jake says here. Good job, get an engineer. Awesome. Let's see what Kieran said, get a structural engineer. Very good. You can do a little bit yourself, strips, footings and piers for Lachlan. Yep, you're going to need somebody to specify the size of the concrete. Refer to an engineer. That's good. You can all have a little green badge on the top right of your screen because you're filled that in. So let's just have a quick look at some activities that you've got for tonight. Now, there's a couple of simple quizzes, 3 of them, and there's one little submission activity. So I'm going to work through this with you. And do we want to leave the recording running, Glenn, while I work through this? I might just check the chat box here. We say, if an engineer under-engineers your footings, piers, and something happens, Sam has said, that comes back on the builder. Yeah. Well, the builder has insurance, but the engineer has insurance and coverage for that as well. Ultimately, things like that, Sam, can go to court if they're real big, but you would stand a lot better if you've built and been approved for the build with the inspectors that you've built correctly. According to the engineer's details, you would be covered a lot more than if you didn't have those engineer's details. So definitely go for engineer's details. It's all changed now, thanks, Han. There are changes and things that are happening, and there's going to be a lot happening now because of these big buildings in Sydney. But you pretty much want to get a good, reputable inspector, and don't just grab somebody with word of mouth and just a phone call. You'll want to see quotes these days for all these things and written documentation that goes with it so that you can make sure you cover yourself well. A builder once told me, pretty much when I build a house, I'm trying to get out of all responsibility that I can. So the first thing I do when I do set out is I get a surveyor to set it out and give me a certificate to say it's correct. That way it's back on him if it's in the wrong spot. Then I'll get an engineer to engineer things, and it's back on them if it's in the wrong spot. And then I'm going to get as many other people as I can who are professionals to give the quote and to confirm that that things are done correctly, so that I can be sure that I've got things, so that I've got somebody else I can call back on. Sometimes that's real hard, but you've got to at least try for it. So the activities tonight are pretty straightforward. I'm going to open all of them because some of you are real fast, but I'm just going to go through. I'm just going to quickly go through a couple of them here and have a look at them for you. This first one here, basically, you can see I've looked at it a few times. Basically, there's a couple of quick questions, and there's no reason why this shouldn't be done you shouldn't be able to do this real quickly. So pretty much it says select the correct soil type for a Class S classification. You're going to need your Australian standard open for this. You can find your Australian standard at the top of the page for, I'll just open S3 here. You can find your Australian standard at the top of the page for every one of these structures lessons. Now I put in here for you in the builder's file package, the Mr. and Mrs. plans, Smith plans. So that's under every lesson. This particular document is under every lesson, and there's the Mr. and Mrs. Smith plan. There's Australian 28 standard 2870. Just beware, because there used to be a rule that if you downloaded this and if you didn't, after about 24 hours, the pictures go blank on it. So if that's the case, then you can just download it again and just use it fresh off the Australian standard site. And that's going to be found back at the top of every single page for this structures unit, up the top here. So for Riverina, we just go there, put your username, password in, and each of you can go there. And it's a thing that you have anywhere in the world just by going to Google and going e-resources for TAFE, and that'll take you straight to the subscription. That's worth probably, I don't know, maybe under 1,000, but it's pretty dear per year to get access to all of that. And TAFE buys a whole heap of licenses. So if you try and get on one time and you can't, it probably means that everybody else has tried at the same time. But when you log on to there, it'll pretty much open up your details, and then I think it'll just allow you to go on and search any Australian standard, and everybody's will look like that. You can see there's 2870 because I just looked at it today and did that. So pretty much you're going to need to jump on there, and you get that quiz open like I've got here. And look, if you push that little middle button there, you can drag that over there. And if you push this little middle button up here, you can drag this one over to here, and you can probably answer them. I'm just going to drag this down here because it might fit a little bit better. Let's get it up here like this, and you can do your quiz real quick. Get yourself a little green point thing, and then be on your way. So, let's get ourselves a little green badge here. I'll help you do one, eh? That's a bit too big. just got a on the corner here, and I've got to go across here. Oh, I've mucked it up there now. Site classification. Where was I there? There's your site classification. And I think that's where we were. Get back to here. Select the correct. So we've got S. It says slightly reactive clay sites. So I'd drag that up there like that. See how you feel about that. Have a go at the next one. And this particular one, there's E. It's not real hard, is it? So you can all have a go at that. Ooh, here's E. Extremely reactive. So we just drag it up like that. And just keep working your way through those, all right? Anybody having trouble with that? Boss wore 80% of the blame. Riley was saying, even though they had nothing to do with it. So you really got to make sure you cover yourself legally. Look, you guys really need to make sure when you start doing building that you've got a legal person who can help you with questions like this. So you cover yourselves. It's going to cost you maybe a little bit for the initial consultations, but you should have someone who you can get on call that you can quickly shoot them an email anytime and they can reply to you whenever. And they'll just save up their little bill and give you a little bill each year or each few months. But you need to be able to get professional advice from somebody who knows all the latest rules and can put up a defensible argument in court if ever it comes to that. You can't deal with some of this stuff all by yourselves. So here's our M, that's moderately reactive. I'm just going real quick here, so I might be choosing the wrong one just in my haste. But pretty much you just work your way through and you can see that you can answer these questions real easy. Scroll the table down at the top. The table at the top, I'll just show you how to find that table. When you get Australian standards, the beginning of it's going to look like this. And over on the left-hand side, you want to try and get a bookmark. You get it by clicking on that little bookmark tab there. Sometimes that can get lost, but it's real helpful because then you just go straight to site classification and you just scroll down and there's your table. There's so much information in here, it's unbelievable. It's really handy for designing this type of thing. So you just work your way through these questions, and I'm going to let you all finish that one off because I think some of you have already probably done it. You should be able to quickly whiz your way through and finish that. And then I want to go back down and I'll give you a few minutes to finish that off. That shouldn't take too long at all. And then what's it now? 6:45 on my little clock down the bottom here. How about at 6:50? We'll come back and I'll quickly show you the next quiz. Because in the next 5 minutes, you should be able to get that one done and locked away. And in the meantime, those of you who are a bit fast, you jump onto the second quiz. But if you're still working on that first one, just keep going with that. See you, Michael. All the best, hey? All the best. Yeah. So we got 12 people have had a go at that second one already. You just keep working on that first one and finish it. There's only a couple of questions in that next one, so you can work your way through this.
Adrian, can you hear?
Yes, go, Glenn.
Do you want me to stop the recording or would you rather go through the activities? Up to you.
You probably could stop the recording and then just start it with help for tonight's activities, if you like.
Yeah.
No, actually, I think just stop it. We're done there now.
It's mainly the quizzes.
Yeah, I'm just going through the activities and quizzes and they'll be able to do that, okay?
Okay, done. I'll stop it.
Thanks.
See you later.